James B. Eads, master engineer who tamed the Mississippi River. James Buchanan Eads, a name revered among engineers, yet often overlooked in mainstream history. A visionary whose engineering prowess reshaped the United States infrastructure during the 19th century. Today, we delve deep into the life and achievements of one of America's greatest civil engineers. From his innovative salvaging techniques on the treacherous Mississippi River to his groundbreaking designs of ironclad gunboats during the Civil War and the construction of the iconic Eads Bridge, his contributions were nothing short of revolutionary. Join us as we explore the technical mastery and unwavering determination of James B. Eads, a man who transformed challenges into legacies. Early life and fascination with engineering. Born on May 23, 1820, in Lawrenceburg, Indiana, James Buchanan Eads was introduced to a world on the cusp of industrial transformation. His family soon moved to Cincinnati, Ohio, where his father, Thomas Eads, attempted various business ventures. Financial hardships plagued the family when Thomas's business endeavors failed, prompting a move to Louisville, Kentucky, in search of better opportunities. At 9 years old, during the steamboat journey from Cincinnati to Louisville, young James became enthralled by the vessel's engine room, the intricate mechanics, the rhythmic motion of pistons, and the sheer power captivated him. He incessantly questioned the steamboat's engineer, absorbing every detail of the machinery. Recognizing his son's burgeoning passion, Thomas Eads encouraged James's interest by building him a workshop. With limited resources and minimal formal instruction, James constructed functional models of sawmills, fire engines, and steamboats. These early projects not only showcased his innate mechanical aptitude, but also laid the foundation for his future innovations. Adversity and resourcefulness in St. Louis. Misfortune struck again when the family decided to move further west to St. Louis, Missouri. As they approached their destination, the steamboat carrying them caught fire. The Eads family narrowly escaped with their lives, arriving in St. Louis destitute. Undeterred, James's mother, Ann Eads, exhibited remarkable resilience. She quickly rented a house and began taking in boarders to support the family. Inspired by his mother's fortitude, the 13-year-old James sought employment to alleviate their financial burden. Facing rejection due to his youth and frail physique, James devised an entrepreneurial strategy. He approached a fruit vendor, proposing to sell apples on commission. His initiative and honesty impressed the vendor. By day's end, James had sold multiple baskets, establishing a steady income stream. His industriousness caught the attention of a mercantile firm owner staying at his mother's boarding house. Impressed, the merchant offered James a position. More importantly, he granted James access to his personal library, rich with texts on mechanics, engineering, and mathematics. This self-education would prove invaluable. Self-education and mastery of engineering. James immersed himself in advanced studies, poring over works like Smeaton's experimental papers on the power of water and wind to turn mills, and Ferry's treatise on the steam engine. His understanding transcended theoretical knowledge. He sought practical application. He frequented local workshops and factories, engaging with engineers and mechanics. His astute questions and grasp of complex concepts earned him mentorships that bridged the gap between theory and practice. Eads' fascination with the Mississippi River grew. Recognizing the river's significance to commerce and its notorious navigational challenges, he resolved to master its intricacies. His studies encompassed hydrostatics, fluid dynamics, and the geological behaviors of river sediments. Understanding the Mississippi River. The Mississippi River, extending over 2,340 miles, drains approximately 1.2 million square miles, nearly one-third of the continental United States. Its average discharge at the mouth is about 600,000 cubic feet per second, but this can surge to over 1.5 million feet per second during floods. Annually, the river transports an estimated 210 million metric tons of sediment. Its banks, composed largely of alluvial soil, are susceptible to erosion, leading to constant shifts in the river's course. These dynamics create hazards such as sandbars and submerged snags, sunken trees capable of ripping through hulls. Pilots navigating the Mississippi needed acute awareness and adaptability. Eads' comprehensive understanding of these challenges positioned him uniquely to devise solutions. the wrecking company venture. In 1842, at the age of 22, Eads founded the Marine Railway and Salvage Company, later known simply as Eads Wrecking Company. Recognizing the lucrative potential in salvaging sunken vessels and their cargo, he innovated methods for recovery. He designed a diving bell apparatus, allowing workers to access wrecks at depths exceeding 50 feet, a remarkable feat at the time. Additionally, he developed centrifugal pumps capable of removing sediment from around submerged hulls. The company's success was amplified by agreements with insurance firms, often granting Eads a significant percentage, sometimes up to 50%, of the recovered cargo's value. Within a decade, his enterprise had salvaged numerous vessels, contributing to safer navigation and earning Eads substantial wealth. Personal life and setbacks. In 1845, Eads married Martha Dillon, solidifying his personal life amidst professional endeavors. Seeking to diversify, he invested in the St. Louis Glass Works, the first glass manufacturing facility west of the Mississippi. Despite his engineering acumen, the venture faced insurmountable challenges, including supply issues and competition from established Eastern manufacturers. After 2 years, the factory ceased operations, leaving Eads $25,000 in debt, a significant sum equivalent to approximately $800,000 today. Demonstrating unwavering integrity, Eads returned to the wrecking business with renewed vigor. By 1857, not only had he repaid his debts, but he also accumulated wealth exceeding his prior fortunes. Contributions during the Civil War. The onset of the Civil War in 1861 thrust the Mississippi River into strategic prominence. Control of the river was vital for the Union's Anaconda Plan, aiming to bisect the Confederacy and restrict their supply lines. President Abraham Lincoln, upon the recommendation of Attorney General Edward Bates, summoned Eads for his expertise in river operations and engineering. Recognizing the need for armored, shallow-draft vessels, the Navy contracted Eads to construct a fleet of ironclad gunboats. Tasked with an almost impossible deadline, Eads proposed the completion of 7 ironclads in just 65 days, a feat requiring unprecedented coordination. These vessels, known as City-class ironclads, were 175 feet long with a beam of 51 feet and drafted only 6 feet, ideal for river navigation. Mobilizing over 4,000 workers across Missouri, Illinois, Ohio, and Kentucky, Eads orchestrated a logistical marvel. Resources were scarce due to the war. Nevertheless, he sourced iron plating, steam engines, and armaments from multiple states, utilizing telegraph communication extensively. Despite delays caused by bureaucratic hurdles, the first ironclad, the USS St. Louis, later renamed Baron de Kalb, was launched in October 1861. The fleet played pivotal roles in battles such as Fort Henry and Fort Donelson, contributing significantly to Union victories. Historians like Admiral David D. Porter later acknowledged Eads' indispensable contributions, noting that without his vessels, control of the Mississippi might have been unattainable for the Union. Post-war achievements, the Eads Bridge. After the war, the expansion of the railroad network highlighted the need for a bridge connecting St. Louis to the eastern rail lines across the Mississippi. Eads proposed a steel arch bridge, a radical departure from traditional designs. The Eads Bridge, as it came to be known, featured 3 spans, the central span being 520 feet, flanked by 2 502-foot spans, the longest arch spans at the time. Eads insisted on using alloy steel, a novel material, enhancing the bridge's strength and durability. One of the significant engineering challenges was constructing the bridge piers on bedrock 100 feet below the riverbed. Eads pioneered the use of pneumatic caissons in the United States, allowing workers to excavate underwater in pressurized conditions. This method, however, introduced caisson disease, or decompression sickness. Eads implemented protocols to mitigate risks, contributing to medical understanding of the condition. Completed in 1874 at a cost of nearly $10 million, approximately $220 million today, the Eads Bridge was a monumental achievement. It not only showcased innovative engineering techniques, but also set standards for future bridge construction worldwide. The Mississippi River Jetties. Despite the river's importance, navigation from New Orleans to the Gulf of Mexico was impeded by sediment deposition at the river's multiple mouths, forming sandbars that restricted ship drafts to less than 15 feet. Eads proposed an ingenious solution rooted in fluid mechanics: constrict the river's width at its mouth to increase velocity, thereby enhancing its sediment-carrying capacity and scouring the channel deeper. Focusing on the South Pass, he constructed parallel jetties extending into the Gulf using willow mattresses weighted with stone, all designed to withstand hydrodynamic forces and promote sediment transport. Within 2 years, the channel depth increased from less than 15 feet to over 30 feet, accommodating the era's largest ships. The success of the jetties revolutionized river engineering and affirmed Eads' theories. Consequently, trade through New Orleans burgeoned, solidifying its status as a critical port and stimulating economic growth throughout the Mississippi Valley. Later years and ambitious projects. International acclaim followed. In 1884, Eads received the Albert Medal from the Royal Society of Arts in London, recognizing his services rendered to science and engineering. His relentless pursuit of engineering solutions led him to propose an interoceanic ship railway across the Isthmus of Tehuantepec in Mexico, a project intended to rival the proposed Panama Canal. Eads envisioned a 134-mile railway capable of transporting ships up to 8,000 tons. His design included multiple tracks to distribute weight and hydraulic systems to secure vessels during transit. Death and unfinished work. Even as his health waned, Eads remained intellectually active. He stated, "I cannot die. My work is not yet done." His determination, however, could not forestall the inevitable. On March 8, 1887, James B. Eads passed away in Nassau, Bahamas, at the age of 66. His death marked the end of a prolific career that left an indelible mark on civil engineering and river navigation. Though his ambitious ship railway remained unbuilt, Eads' legacy endures. His innovative approaches set precedents in engineering, demonstrating how empirical science could solve complex infrastructural challenges. His life story serves as an inspiration. For aspiring engineers and experts alike, Eads exemplifies how technical expertise, when combined with tenacity and ethical commitment, can overcome formidable obstacles. James B. Eads' journey is a testament to human ingenuity. His work on the Mississippi River not only tamed one of nature's most formidable forces, but also propelled economic growth and technological advancement. Eads' methodologies and innovative spirit continue to influence modern engineering. His approach underscores the importance of interdisciplinary knowledge, rigorous analysis, and practical application. As we reflect on his contributions, let us remember his words. Engineering is the art of directing the great sources of power in nature for the use and convenience of man. May his legacy inspire future generations to push the boundaries of what is possible.